right, so we finished up the WikiSticks activity, and if you're listening to this because you were absent, you need to go and look at the pictures of that so that you know what I'm talking about. And we're looking at slope fields. Okay, these are pretty big slope fields. These have a lot of points. This would have taken a really long time to create. All right, but that's not really what I'm going to ask you first. I really just want to know first, what shape or what parent function do you think this makes? And if you needed to, you could kind of follow along. Like, what is that? That's a horrible drawing of what?
Cosine? Sine?
It could be sine or cosine. Really, I'm really just asking you about parent function here. It looks more like sine. Okay? But we know that cosine with just an easy horizontal shift looks the same as sine. All right, what about this one over here on the right?
Oh, it's going to be
What parent function?
It
looks like it could be tangent. However, what is tangent? Listen, what does tangent have on the sides? Asymptotes. I don't see the asymptotes. That doesn't mean that if we went out further, they wouldn't be there. So I don't, maybe tangent. Or what other parent function does this look like? X cubed. Cotangent wasn't a bad thought either. So cubic. If you have an idea of what the parent function should be at the slope field, it's going to make the next part easier when we start integrating and getting what the solution curve is going to be. Now, this next part of your notes talks about how to graph a slope field on your 89. I am going to do this tomorrow because you will never get to use your calculator when doing slope fields in here. All right, and you won't get to on the AP test either. This is really just for your information and to kind of check your work. Okay, we're going to look at that more tomorrow. What I want to do for the rest of today is to go through a whole slope field problem. Okay, and tomorrow, like I said, we're going to continue this. So this could have been the problem that you were given. All right, and this really was one of my 7. Nobody in here got this one. But in my other classes, some people actually, this is the one that they did. Now, I like kind of doing this as an example because it has an X and a Y. Some of you only had X's and some of you only had Y's, and you started noticing a lot of patterns. Okay, and that's what we're going to talk about here. If there was only an X, then what would be true about my columns?
It would be the same.
They would be the same. And if there was only a Y, I think you girls back there had the one with only Y, what did you notice? The rows were the same. And so that noticing those kinds of patterns really make this easier. I'm having a very difficult time drawing straight lines today. That's okay. All right, so if you're like, I don't know where to start, draw a little X, Y, M column. M stands for slope here. And what you're going to do is you're going to just start with wherever you want to start. 0, and in fact, I'm going to stop there because if X is 0, does it even really matter what Y is? Doesn't even matter. Okay, I'll put a question mark there. 0 divided by some other number should be 0. And if a slope is 0, what type of line segment is that going to be? Horizontal. Okay, so that's going to be true for all of these. Now I'm going to skip over 0, 0. I'm going to skip over that one for now. Okay, what about if Y is 0? Speaking of patterns, there's another one here. Okay, forgetting what X is, if Y is 0, what's a number divided by 0? It's undefined, which is going to cause a vertical line. So all of these points right here, we have a vertical line. Now again, I'm skipping over 0, 0. Because 0 over 0 is not 1, it's not 0, it's not undefined. It is undefined, but it's a different category of undefined. We're just going to skip over 0, 0. We're not even going to put anything there. Okay, if you did, though, it's not going to mess up your slope field. All right, so if you're like, I don't know where to go from here, let's just pick a point, 1, 1. And let's plug in the 1 in for X and 1 in for Y. So what would your slope be at the point 1, 1? Negative 1. So make sure, first of all, that your slope is negative, that it's decreasing. a slope of 1 or -1 isn't going to be really steep and it isn't going to be really flat. That's all you really need to know. You don't have to like get a ruler out and make sure it's exactly a slope of 1. It just needs to be not steep and not flat. Okay, I already told you, the more you recognize patterns, the easier this is going to be for you. Is there any other point on here that's also going to give me a slope of -1?
-1, -1.
Yeah, 2, 2, 3, 3, -1, -1, -2, -2, -3, -3. So I could have done all those points separately over here off to the side, but you really don't have to if you notice the pattern. Okay, this over here is just there to help you until you notice the patterns. Okay, what's another point we could do? Anybody want to throw out a point?
2, 1.
I'll do 2, 1, 1, 2. It doesn't matter what we did. 2, 1. That would be -2 over 1, which would be -2. Remember, we're just plugging the coordinates into the dy over dx. So then a slope of -2 is still going to be going down, but it's going to be steeper. It's going to be steeper than the -1. How steep? Well, just steeper, okay? You don't have to be 100% accurate here. You just need to be in the right ballpark. And I don't even need to write this down to know this is even going to be steeper. Okay, so I want you to finish this on your own. And when you're done, look up here and kind of check your work. But I don't want you just to copy me. I want you to really try it on your own and then check it. If you've already finished, go ahead and check up here. If you're keep working if you're not done yet. And if you're already checked, good to go, go ahead and answer the questions A through D. Okay, wherever you're at, go ahead and check them up here. If you're not quite done, that's okay. You can keep working. If you're able to do half of this right, you could do the rest of it. Okay, some of you did this really quick. How did you, those of you who finished really quick, what did you do? Like, what patterns did you recognize? Okay, so let me ask you this. As the points got further and further away from the center, like going to the left and the right, what did that tell us about the steepness of the slope? Did it get steeper or did it get flatter? As we went away from the middle. It got steeper because the x value got bigger. Okay, as you went further away from the middle up and down, okay, it actually got flatter because the y value was getting bigger. You don't have to recognize these patterns. You don't have to. But if you do, it will make you more efficient at this. Okay? You could, though, for all purposes, just do an XYM chart for every single point on the whole grid. That would work. All right, so I'm going to go ahead and move on to the next part. which is sketching the solution curve. Some of you had a hard time with this in the wiki stick activity. This is where you put the long wiki stick in. Okay, what you always want to do is start with the point that they tell you to start with, 0, 1. Now, if you have like a highlighter or a pen of a different color, go ahead and get that out, and so that it'll really stand out against your slope field. And you want to start with graphing that point. Now, from this point, you want to follow the trend of the slope field. So I want you to watch what I'm doing here. I'm going to go to the left. Now, this piece right here tells me that the slope should be about -1. Okay, and this tells me that the slope should be vertical. And so I'm following the slope field. It's telling me how steep my graph should be and when I need to turn around. Now, I also know what this is going to look like, but once I graph it, what shape did I just make? A circle. I made a circle, and what's the radius of this circle? 1. All right, what's going to happen if instead of starting at 0, 1, we start at 0, -1? What is that circle going to look like? Because really, now that we know the answer circle, every single thing we graph should be a circle. It just might not have the same radius. So what do you guys think about B? It would be the same because it starts right here, and if I graphed it, it would still be a circle of 1. Now, it kind of looks more like an oval, probably on your paper. That's more or less because the tick marks are further apart on the x-axis. So it ends up being the same circle, and I wanted to kind of show you that so that you can see that you could have started different points and have the same solution curve. All right, these are called your initial conditions, by the way. This is how we're going to find that plus C when we integrate. All right, to do the next piece, you need to know your parent functions. That's all there is to it. We already know the solution curve is a circle. So when I say, could this be a slope field for this equation, what I'm really asking you is, does this thing make a circle? No, it doesn't make a circle. All right, what about square root of x? Does that make a circle? No. What about x squared plus y squared equals 2? Yes, it doesn't make our circle, that makes a circle. Okay, so it could be a solution curve. This would have a different initial condition. All right, so now we're going to actually solve this thing. This is the thing I'm going to kind of end on today. So the first thing I want you to do is to rewrite the dy over dx. So this was -x over y. Now, if you are a great memorizer, by the way, you could, if you wanted to, just memorize, hey, the slope field for -x over y, that makes a circle. But I will tell you, we're going to have a lot of these, and you're probably not going to be able to memorize them. Most of the way I'm going to quiz and test you over these are going to be matching and multiple choice and stuff like that. All right, so if you are good at memorizing, use it to your strength, but you don't have to. All right, we are going to solve this separable differential equation, and I even put that word in there just to remind you how to do this. Are we right now ready to integrate both sides? We can only integrate one variable at a time. Thank God. I don't want to start integrating where there's 2 variables on there. That kind of stuff exists, but not here. So we need to get all the y's to the left. So how would I get this y in the denominator to the left? I would multiply by y. All right? This dx is also not at the right spot. So I'm going to multiply that as well. So the first thing you got to do is separate your variables. Have you heard me say that before? Yes. Let me tell you, you have heard me. Do you remember hearing me? That's a whole nother story. But you have heard me say this many, many times. Okay, once you've separated your variables, now you are ready to integrate. What we are doing is we're taking the slope field and we're going backwards. That's why we're integrating. We started off with the derivative, the slope. We're going backwards and we're going to find the equation of that circle. All right, what's the antiderivative of y? 1/2 y squared. Very good. It's just the old add 1 and put the reciprocal in front. The basic rule of integrating. Now, normally I would write a plus c here. I'm not going to do that, and I'm only going to write a single plus c off to the right. Remember, plus c just means plus some constant. So you could have one on the left and on the right. Eventually, you're just going to have one on the right. This is perfectly acceptable to do it this way. I keep making these dots everywhere, and it really is annoying me. Okay. So what is the antiderivative of negative x? Negative 1/2 x squared. You guys see, the power is just 1. I'm just adding 1 to the power 2, and I'm writing the reciprocal in front. It's just the basic rule of integrating. Now, in other problems we're going to look at tomorrow, we're going to have to use substitution, natural log, and all that kind of other stuff. That's why we did integrating before we did this. Okay, now, and I probably should have written this up here, but the standard formula of a circle looks like this. You know, a lot of equations, normally it's y equals this, right? Y equals. But for circles, it's actually x squared plus y squared equals r squared. Does my equation right here look like that? No. First thing is, I got to get this now. I got to move this over to the other side. So that's going to be 1/2 x squared plus 1/2 y squared equals c. And I don't want you right now to be thinking, how am I going to remember all these steps? I just want you to follow them and understand them. Tomorrow, we're going to practice this a lot more, okay? Now I have this 1/2 in the way. What could I do to both sides so that the 1/2s will go away? Multiply by 2, or I could have divided by 1/2. It would work out either way. So I distribute, right? Distribute to everything. And that gives me x squared plus y squared equals what?
2c.
All right, I'm hearing 2c. What does c stand for? You're not wrong.
Just any number.
It's just any number. So what is 2c? Just some any number, right?
C.
So it is totally fine to just write c. I call this being loosey-goosey. You're kind of just being real, like, c is changing values and we're being real loose with it. That's fine. You can be real loosey-goosey with c until you get to the point where you plug in your point. C is just a constant. If you add a number to it, it's still a constant. If you multiply, it's still a constant and all that. Okay, that's perfectly fine. But once you get to this step, when you plug in your initial condition, so in place of x, I'm going to plug in 0. In place of y, I'm going to plug in 1. Okay, I'm getting all of that from this initial condition up here. All right, so what does c equal? 1. Okay, c equals 1 now. It's not some unknown constant. It equals 1. So my final answer is going to be x squared plus y squared equals 1. I now no longer have a c. I couldn't just multiply by 2 now and still call it 1. Okay, when you plug in your initial condition, you're stuck with whatever number you get. Okay, is this equation fit the circle that we drew up here? Yeah, the radius was 1, right? Because it equals the radius squared. Now, you may not, we haven't graphed circles in here, okay? But, so this was kind of a review part. All right.